Hello and welcome once again. Today we're going to delve again into these type of schematics to show you different types of schematics. We went over it before for Toyotas, for Hondas, for anything, for all Asian cars. Now, again, this is the starting system. As you can see here, this is a pictorial of the generator. Where do we start from? We always start from main components. What's a main component? In this case, the generator, the alternator, the starter, the relay, ignition switch. We don't worry about the connections in between. We don't worry about the wires, the color of the wires. We don't worry about junction connectors, which is very popular with these Asian cars. Only worry about the main components. And it'll make it much easier to analyze. Now, you know an ignition switch can have accessories, lock position, run position, start position. In this one over here, it's a little different. Ignition switch for Toyota Camry. This is ganged together. You see this dotted line? They are ganged together. What does that mean? That means when this pivots, when this moves one position, this moves one position. So right now, according to this diagram, they're in the rest position. They are not making any contact to this one or this one. For this one, AM1 is not making contact to accessories or ignition 1. AM2 is not making contact to ignition 2, which I call run, or this one called start position. When I activate it, I'm going to put it in the position. I'm going to pivot it. When I pivot it, this one, AM1, goes to accessories, which has no connection. No problem then. This one will also pivot at the same time. Where will it go? If this one went one slot, this one will go one slot. So top one, the accessories, bottom one, AM2, will be in the run position or what they call ignition 2. Let's concentrate on that position, ignition 2. What will happen? This is tricky, but it's a challenge. But if you understand this, you have improved in your analyzation and troubleshooting methods. Let's start here. Let's follow this arrow over here. We said we're going to put this, AM2 is going to be connected to ignition 2 on the run position. Follow this line from the ignition switch. Follow this one, the thin green one, and it goes to F8, 7.5. Again, we're not concerned about the wiring and all this. It goes to C11, charge warning light. That's the light that comes on, either a battery light or a charging system warning light to tell you the charging system is not charging the battery. You don't have enough voltage from the charging system, the alternator. Where does it go? It goes right here, to here, through a fuse, through a diode. This is called a diode. We'll explain in a second. And this is a bulb that comes on. And it goes to this terminal of the alternator, B, which is the L. So now, what's the purpose of this? You see this bulb is turned on when your charging system has not been activated enough. And that's going to be first in the run position, obviously. Because why? Your engine is not cranking. If your engine is not cranking, alternator is not working. So, do we expect this to happen? Yes, we should happen. Yes, this should happen. We should see the light go on when in the run position. Now, in the run position, what happens? In run position, let's say for GMs, the car does something called initialization checks. It checks all the parameters, and it checks also the communications. Let's say the PCM or the BCM, it makes sure that the computers can communicate with each other. If, for whatever reason, the computers cannot, the modules, as they're referred to, cannot communicate with each other, you will not start the car. You'll turn the key, but nothing will happen. The computer will not allow you. This is what happens in the run position. That's why when you go to the dashboard, on those gauges, you know what you'll see all the lights come on. It's a checklist almost. It's almost like a boot up. When your computer checks for the keyboard, for the mouse, when you first turn it on, same idea, same principle. So, with that, Number two, we said, what's the diode for? The diode is over here to make sure that the battery is connected correctly. A diode can only work in one direction. This is called the anode, and the other one is called the cathode. Anyway, this is a protection device to make sure that the positive of the battery is connected to this. If the negative is connected, this will not conduct. This will only conduct the one way when the positive is connected to this anode. If I flip the battery cables by mistake and I put a negative, guess what? We're going to save the alternator from damage. That's its purpose. So it's like a one-way street. You can only go one way, but you cannot go the other way into the street. Think of it that way. Let's delve into it a little more complex now. Let's challenge ourselves now. Where did this come from? Follow this line from here to here to here to here to here to here to here. This battery through this fusible block. And Toyotas and all these Asian, they like to have a common multi-fuse, they call slow blow fuse, with two together in the same unit. Like a fusible link over here, or like a fuses over here, a protection device, but it's just in one unit. You replace the whole thing. But let's see. We're going to go through, let's say, we're going to call this a fuse instead of a fusible link. One fuse. Remember, we have to get to here. One fuse. Do we go here? No. We have to go this way. We're concentrating on this point. Here. Another fuse. Through where? Through the ignition switch. In which position? The start position, in the run position. Here. 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 Another fuse. Three fuses. Three protection devices to protect this alternator. Okay? Now, the question. Let's challenge our troubleshooting skills. First thing is, you turn the key in the run position. Right? All the lights come on. As soon as I see it, I see the charging warning light come on, or the battery light come on. What does that tell you? Are the fuses good? Remember, without even putting a multimeter, use those devices, that initialization test to tell you something. And off the bat, that tells me a couple of things. Let's delve into it much deeper. The fact that this is lighting, the bulb is lighting, is telling me what? In this case, it's telling me what? That this fuse is good. What else is it telling me? It's telling me that the ignition switch is good, at least in the run position. I don't know about the start position. I didn't do that yet. I didn't crank yet. But I know at least in the run position, this is good. How do I know? The bulb is lighting. What else does it tell me? It tells me, follow this one, it tells me that this fuse is also good. This 20 amp fuse. What else does it tell me? It tells me at least one of these two 80 amp fusible link or block is also good. So you're going to say, but Joseph, is that true? Yes, it is. Look. Bulb is here. Bulb is lit. One fuse is good. Starter ignition switch is good in this position. That's number 2. Number 3, this one is good. Number 4, this one is good. That told you 4 things without even putting a meter. This is a pro from a meter. Without even putting a meter at this point, without putting a meter at this point, without putting a meter at this point, without putting a meter at this point. This point. You saw yourself when this lit, automatically all the ignition switch must be good, the fuses must be good, without even putting a multimeter on it. This is how you troubleshoot. Use these bulbs, use these malfunction lights and all these things in your dashboard to tell you things. Now, let's say instead of 12 volts, I have 10.5 volts. How do I know? Well, I made a video which I thought would be a little better, to be honest, with views, but obviously, I don't know, it wasn't that popular, I guess. But anyway, the gauges in your car. Use the gauges in your car as an indicator. There is a gauge for your battery. How much your battery is, the voltage. If your battery voltage is not 12 volts when I'm in the run position, and I look at it, it's 10.5 volts. Use that as an indicator to tell you, my problem is not here in this situation with the fuses and with the starter motor. My problem is first to get that battery charged to 12 volts or 12.6 volts. That's my problem. If that battery on that gauge on your dashboard is 10.5 volts, I have no business of even going in this direction over here. I have to recharge that battery or get a boost, whatever it is. That's what my first accomplishment is. Will the dashboard, will the instrument panel go on if I have 10.5 volts? Yes, it can. Because how did you see that it's 10.5 volts in the first place? That must mean that your instrument panel must work at 10.5 volts. Otherwise, you won't see any displays. So if you have a bad ground or bad connection, you won't see anything. Your power doors won't work. Nothing will work. That's first as first. So, again, to reiterate the point, to stress the point, we use this indicator, a little bulb in the indicator in the dashboard that came on for the charging system to tell us the fuses are good, the ignition switch is good. That's how you troubleshoot. Next, this is the tough one. This is the tough one. We said this pivots together. This will be the ignition 1 mode. I'm gonna go now to the start position. What's gonna happen? This will pivot here. AM1 will go here. 2 will go to pin 4. This one, pin 7, will go to pin 8, I believe. Now it's a little different. Where's the connection now? This connection. You see this big 100 amp fusible link in this block? This plays a role in going to another fuse through this ignition switch in ignition 1. Goes through where? Another fuse. It goes to junction, and it goes to the ignition. It goes to the alternator to give it B plus, because after all, there is a regulator over there, transistors and diode, and they need B plus. They need 12 volts DC to start off. Okay, and once the alternator works, then it gives back the DC that was rectified in that position. So, first thing is first. We follow this thick, and I made this thick so you can see it, thick orange line over here, a red line. We're going through this. We're giving him, for the regulator, for over here, 12 volts. That's number 1. That's this one, AM1. AM2, which position are we in? We are in the start position. Okay? Since we are in the start position, we go from the green to where? We did this path. What are we left with? We're left with the orange path, the thick one. We go here, here, here. Now comes the fun. We have a park neutral position switch. We have a choice to go here. When the current goes here, we have a choice for the current. You see this? The current will go, if this is manual transmission, where do we go? We go in this path. If we are AT, automatic transmission, we go in this path. That's the path we're taking. We come to this point. Which path do we take? What do you see here? Let me try to... AT, what does that mean? Automatic transmission. Do we take this path? This manual transmission, do we take this path? We're taking this path. AT, AT, AT. And we're going through a neutral safety switch to make sure you're either in the park or you are in the neutral. Now, let's say you have a RAV4 or something, or a two-wheel drive or four-wheel drive vehicle. If you have a two-wheel drive, this pin will be number 2. If you're on four-wheel drive, you'll be in pin 5. You're coming in this one, you're going out this one. So, let's say I have two-wheel drive. I'm going in pin 2A. I'm coming out pin 3A. If I have four-wheel drive, I'm going in 5B. And I'm going in 6. I'm going out 6B. That's how it works. This is a connection from here to here. So, as long as you're in park or neutral, you can start the car. Current goes here, here, here. To start the primary, but you always start this. This is critical. You always start from this part of the relay. You don't start from this part. First thing that comes to your mind: relay, computer, starter motor. Relay, first thing, the coil. Where's the coil? They call this the control start. This is the first thing. How do we activate this? We activated this through the start of the ignition switch. And then we made sure that we were in park and neutral, not in reverse, not any other selection. So we go here, and we go right to ground. Follow this thick orange. We have a 12 volts where? From here and here. We said before, we can even get a ground from where? The computer or physical ground. Is this a physical ground? That's the radiator, right. This is a physical ground. Again, we don't worry about this junction connectors. We're going with main components. So, what did this help us? We came here. Since this is activated in the start position, right? We went through one component, went through another component to get to this component, to get the ground. Now, we follow this one, this fuse, which is common to this one, common to this one. We go here, 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 here. And now, we go to the solenoid. This gives us a path to get to the solenoid to activate the starter motor. So this is critical. You have to find the current path for this one first. Always, always. If this works to ground, we're in business. We can get the load to be activated, whether it's a pump, a fuel pump, a motor, whatever it is. Current will flow now here to here. This will be closed. Starter relay. 12 volts here, 12 volts over here. How much over here? 12 volts at the solenoid. If you measure 10.5 volts, no. You have to recharge your battery. Maybe you cranked it 2 times, then it got so weak, whatever. But you first have to start with 12 volts. And where's the other point? This is the heavy, thick wire. When you don't see any fuses or fusible links, this one directly from here to here is that thick wire that carries all the amps. It could be 300, 400 amps. That's why you don't see any fuses here for that. So anyway, that's that. Okay? Now, before we get to troubleshooting, and it'll be in a video, I'm already at 17 minutes. What happens after that? You started the starter motor, the flywheel, the crankshaft, the pulleys, the alternator started. When the alternator started, I'm still in the start position, remember. Still holding my key in the start position. What happens? Guess what? Now, from this one, a BA position over here, B1 position, 1A they call it. Go over here, we come back to, through this fusible link, 100 amps, which you use in the first place, through the ignition switch to give it 12 volts. We're now using it what? For what purpose? As a protection to the battery from the alternator when it recharges it. So it's going to go here and replenish the battery. And it's also going to take care of the accessories that need to be taken care of. After all, we're not done with this yet. We're not done with this because still we need some current to go through B plus also to go to the generator. Now, once the engine is cranking, guess what? We go back, like we said. This is 13.3 to 14. Back, replenish this in the start mode. Okay? Now, once I go from start to run, this can still work. Look at this. See? This doesn't go through the switch, the generator. Only to start the starter motor. Once you start the starter motor, then you crank the engine. When you crank the engine, the pulleys turn, the serpentine belt turns. Very important. And the alternator starts creating its AC, which is rectified to DC. That DC comes out here, through here, through here, through here. You see that. Then what happens? Finally, what happens? When we go back to the run position, guess what? Now, the light goes out. All that happens in run and start position. So anyway, this is part 1. Hopefully part 2, I'll do part 2. But this is how you analyze this. It's a lot to understand, but hopefully you understand the basics of it. Please go to my channel, Joe Electronic Schematics for Auto. My other one, Automotive Electronic Schematics by Joseph. Well, if you need hands-on videos on how to test generators or whatever, AC generators, and another point, from here to feed back the battery, over here. This one over here, you make sure that the multi-fuse is intact. If this is blown or melted, guess what? You're not going to have any charging system back to your battery. When that happens, guess what happens? Here, I'm in the run position. Guess what? This will light. This indicator will light. Again, this is the output of the alternator. Going back here to this. This opened up. This is not getting 14 volts. What's it going to get? Whatever that battery charge was at last. Maybe it was 10 volts. Maybe it was 11 volts. Maybe it was 12 volts. Whatever it was. Now you're running on your reserve capacity of your battery. So it's not just the generator. It could be this also, the fusible link. So when that happens, here's the path. Here's the path over here. The path over here from the battery. The battery is still going to come on, and it's going to tell you right here that you have a problem. The charge is not working. Why? Because this fusible link opened up. You still have a path from the battery to send current through this one. Anyway, thanks for watching. Like I said, please go to the videos of how to check battery using a load battery test. It is very important because instead of throwing money out for batteries which are not the problems, you can use a cheap battery tester, $30, and they are pretty reliable for that amount of money. And also how to do the cables, the resistance check across. They're very important instead of having corrosion problems. How many times did I see the customer that came in, they said they changed batteries by the dealerships? That's not the problem. How hard is it to clean corrosion in dealerships? Anyway, thanks for watching.